Hi, my name is Kiana Hechanovs, and today we are going to talk about the solution for our previous quiz about forecasting. So for the first question, data collected on the yearly demand for 50-pound bags of fertilizer at Wallace Garden supply in the following table. So you can actually see the table. And then develop a 3-year moving average to forecast sales. Then estimate demand again with a weighted moving average in which sales in the most recent year are given a way of 2 and sales in the other 2 years are given a way of 1. Which method do you think is the best? So for this, first we have to create the two forecasts, which is the moving average and the weighted average, and which I am going to show you in the next slides. So here I'm showing you the 3-year moving average table. In this forecast, the formula is actually really simple. We just have to add all the data from the previous 3 years for the year we're going to forecast. So that is why the year 1, 2, and 3 is actually there is no forecast for those years because again we are going to use a 3-year data. That is why we are starting at year 4. So for the year 4, we added the 4,000, 6,000, and 4,000 data from year 1 and 2, year 1, 2, and 3, and then divide them into 3 because again this is averaging. So since we use 3 data, then that is the denominator we are going to use, which gave us the result of 4.67 or 4,670 forecast for year 4. And since it is given that the actual demand was actually 5,000 for year 4, this gave us a 0.33 error or discrepancy, or 330 discrepancy. So that's how you actually solve all of the data. So I won't be enumerating each of them. So we're going to move on to the errors. So the errors are significant to get our MAD. So MAD, for the formula, we're just going to add all the errors and then divide them into how many data we have actually used. So it's still the same, averaging, the same method for getting the average, which gave us a MAD of 2.54 or 2,540. Also, if you can observe, we have forecasted the 12th year. Since the datas are there, we just have to use the datas from 11th, 10th, and 9th year, which gave us a forecast of 13.667 or 13,667 for the year 12. So take note of the MAD because this is going to be our guide in which method is actually very useful in this question from the previous question, if you have remembered. So we're going to move to the next table. Now here, I am showing you the 3-year weighted moving average. So in this forecast, it's quite the same with the moving average method, but there is a twist. Each data has its own way. So if you can actually remember, it is given that for the weighted moving average, the nearest year, or the first year that is nearest to the forecasted year, has a way of 2, and the other 2 years have each way of 1. So first we're going to multiply them into their ways and then divide them into the total ways. If you can observe, which is why we have the 4 times 2 plus 6 times 1 plus 4 times 1, since the year 3 has a biggest way, which give us a result of 4.5 or 4,500. And still the fertilizer demand or the actual demand is still the same, which is 5,000, and gave us an error or discrepancy of 500. So again, I won't be enumerating each of the datas or forecast, since I have already discussed how it is computed. So we're going to move to our MAD. So we have a result of MAD. Again, the formula in getting the MAD is just the same as averaging. We just have to add all the errors and then divide them into the how many datas we have gathered from the errors. So we also have forecasted the year 12, since the datas are there, it is available. So we have forecasted, which gave us a forecast of 14 for year 12. And now, please take note of the math, because it is the basis for getting the answer for the question. So the question again was, which method do you think is the best? So to know which method is the best, we are going to base them on their MAD results. So for the MAD results, the lesser it is, or the nearest it is to 1, it is better used. So since, if you can remember, for the moving average we have 2.54, and for the weighted moving average we have 3.31. This only means that since the weighted moving average MAD was actually lesser than the moving average, then it is better to be used, or this is the method to be used in forecasting for this problem. So here is the next question. Three different forecasts were developed for the demand for fertilizer. These three forecasts are a 3-year moving average, a weighted moving average, and a trend line. Which one would you use? Explain your answer. So since the data are still the same, and we already have solved the first two methods, the 3-year moving average and the 3-year weighted moving average, we're just going to show you the trend line method. So it will be presented to you in the next slide. Here's the trend line forecast table. In this method, it's actually quite different from the previous two we have just solved. So for the trend line formula, we have y is equal to a plus bx, where a is 2.22 and b is 1.05, and our x would be the year we're going to forecast. So if you have already solved a and b, then it's going to be smooth and simple. So since we already have a and b, and then we're just going to change x into the years. So 1, 2, 3, 4, 5, and 6, and up to 12. So with that, for the year 1, with the actual demand of 4,000, we have a result for a forecast of 3,370. Again, these are in thousands, or 3.37, which has a discrepancy for the actual demand of 0.73, or 730. So again, you already know how to get the discrepancy or the errors. So I won't be enumerating again each of them. And with that, we have a MAD result of 1.39, or 1,390. And this is very simple, since we already have the MAD results for the what was that? The 3-year moving average and the weighted moving average. And to get the better method to be used, again, it's the least, or the nearest to 1 MAD is the best to be used. And since the trend line actually has a 1.39 or 1390 mad, then it's obvious that it's way lesser than the two previous methods. So therefore, for this question, the best method to be used would be the trend line forecast. So here's the last problem. Use exponential smoothing with a smoothing constant of 0.3 to forecast the demand for fertilizer given in problem. Assume that the last period's forecast for year 1 is 5,000 bags to begin the procedure. Would you prefer to use the exponential smoothing model or the weighted average model developed in problem? Explain your answer. So for this problem, let's move to the next slide. So since we've already solved the weighted moving average model, we're going to proceed with our exponential smoothing model, which is here. The formula for this model is the following. F1 is equal to Ft minus 1 plus A, and then times the St minus 1 minus Ft minus 1, where our Ft minus 1 is equal to forecast last period, our St minus 1 is equal to the sales of the last period, and our A is the given smoothing constant of 0.3. And if you have observed, it was already said earlier that to start the procedure, 5,000 is given as the forecast of the first year. That is why we have 5,000 there. So we're going to proceed to the year 2. So we're just gonna have to replace all the equivalents of that formula. For Ft minus 1, it was forecast for the last period, and since the forecast was already given for the year 1, it was 5,000, so we're just gonna replace that to 5,000, plus A, which is the smoothing constant of 0.3, and multiplied to the St minus 1, which is the sales of the last period, which is already given, the actual demand, which is equivalent to 4,000, minus Ft minus 1, again, it's our 5,000, which gives us a forecast of 4,700. And if you're going to deduct that or demand for that year, we are going to have an error of 1,300. So that's just how you're gonna solve this model. So I won't be enumerating all of them. So I guess you have already understood how to solve that one. And so we're going to move to our MAD. Again, our MAD, simply just add all the errors and then divide them into how many datas we have gathered, which is 11, and then we're going to come up with the 437 or 2.437. So if you remember, for our weighted average, for the weighted average method, weighted moving average, we actually have a MAD of 2.31. So if you are going to compare it to our exponential smoothing, we have 2.43. So since, again, weighted moving average was less than this method or the exponential smoothing, we are going to choose the weighted moving average. So it just means that the best method to be used in this problem is the weighted moving average model. I guess that would be all. Thank you for listening, and I hope that I really helped you in understanding how to solve our quiz the last time. Thank you.